Good afternoon, everybody. Welcome to our Startup Speaker Series. For those who don't know me, I'm Aaron Anderson, the Director of the Student Startup Center here at UC Davis. Really excited today to have a particularly special guest. Our goal today is to have a quick power conversation. But it is my pleasure to introduce Sterling Anderson, a founder and chief product officer at Aurora, a self-driving car tech company. I've known Sterling for a few years, but by all means, his reputation precedes him. Sterling, thank you so much for joining us. Let's give him a round of applause. But Sterling, let's level set with everybody. Can you, before we do anything else, tell us about Aurora, what your company does, what problem you're trying to solve?
Yeah, it's nice to meet you all, Aaron. And Aaron, thank you for having me on. I look forward through this conversation maybe to get to know a few of you a little bit better. But a little bit of context on Aurora. We are, as Aaron said, a self-driving technology company. What that means is we established the company about 4.5 years ago with the mission of delivering the benefits of self-driving technology safely, quickly, and broadly across several industries and use cases. What that means is developing the hardware, the software, and the data services required to allow a vehicle, whether it's a Class 8 truck moving goods or a passenger vehicle moving people, to operate itself without a human. That delivers several significant benefits to society. The direct benefits being safety, improved safety of our roadways. 1.25 million people lose their lives on the world's roadways each year, and we can make that much, much better. Another is efficiency. So today in the United States, there are 60,000 truck driver positions that are going unfilled. That will only rise as the current demographic ages out. Further, drivers of these vehicles, whether it's a human driving an Uber or a Lyft, or someone driving a truck, can be very inefficient about that in two ways. First, their management of the throttle and brake effectively on the vehicle leads them to use much more fuel than they need to. And second, they can only operate for about 11 hours a day before they have to stop and take a rest. The good news is a self-driving system need not eat, sleep, or take breaks. And the result is that you can re-optimize logistics networks around a system whose utilization can be very close to 100%. And so, for instance, imagine for a moment, if you're Amazon or eBay or any other kind of major e-commerce player, and you suddenly can achieve the convenience of truck shipping at the cost of rail and the speed of air, effectively moving an entire trailer of goods from, for instance, LA to Dallas, in what takes today 3 days for a human, it takes 24 hours for an Aurora truck to do that. And so it is a game changer as it relates to many of these industries. In ride hailing, many of you have, I would assume at this point, ridden in an Uber or a Lyft vehicle. It's an enormously price elastic market. And what I mean by that is as the price declines, utilization goes way, way up. And the opportunity of a self-driving system is to drive much further price declines, improve the experience, allow far more people to use these. And the secondary benefits that society reaps from that are fewer vehicles owned, less of our most precious space in our homes and in our cities being dedicated to parking, and shared vehicles that are much more efficient for society being the primary mode of operation for most people. So that's what Aurora is about.
Awesome. Well, so I mean, the technology, I got to imagine is super complicated. A lot of folks, going after this space, trying to make big headway in self-driving vehicles. Can you tell us about some of those technical challenges? Like, what problems do you have to navigate as you build the technology? What is hard?
Sure. Yeah. To put it in context, just the sense of the magnitude of the technical challenge here, which Tim Cook over at Apple has called the most challenging technical problem of more than a century. Many perceive it that way. It's this century's, this decade's moonshot that really is very, very difficult. But to put that in context, many of you, if I were to ask, hey, how are humans as drivers? You would probably roll your eyes and say, oh, they're terrible, right? Humans are terrible drivers. They do goofy things, dumb things all the time. My response to that would be yes, they do. That's part of what makes driving on sharing roadways with them difficult. But what I'll also remind you of or tell you about is in the United States, Approximately one fatality happens per 88 million vehicle miles traveled on our roadways. And let's just do a little bit of arithmetic here on kind of what that means for an individual user, right? If it's one fatality per 88 million vehicle miles traveled, and you assume the average American travels about 13,500 miles per year, we're talking about 6,700 years of driving. If you assume the average person drives for, I don't know, 65 years of their life, we're talking about more than 100 lifetimes of driving for one fatality on the road. 100 lifetimes of driving. Imagine for a moment, most of you have driven, what, a quarter of your driving lifetime, max a half of your driving lifetime. Think of all the weird things you've encountered as you've driven that much. Now imagine 100, 200, 400 times that before you've got one fatality. And that starts to put in perspective the sheer technical difficulty of this problem. It's got to be actually really, really good to exceed the performance bar set by humans. And so the challenge then becomes that of how do we operate a vehicle safer than a human does on roadways shared with humans who are inherently unpredictable? And it starts to get into some really tricky technical problems related to a thing called perception, which is to say perceiving or understanding the world around you and the people in it, or the things in it, to prediction or forecasting, understanding and predicting accurately how those things are going to move through the world, to motion planning, decision making, determining what actions you're going to take based on the rules of the road, other actors in the world, and what they're each doing, all the way to control of the vehicle in terms of kind of executing that plan. And so these are kind of the major kind of functional pieces of the problem that get solved. But the solution space has to span everything from hardware development, develop those sensors, LiDAR, radar, camera sensors that allow you to put together these perception algorithms, to the computational systems, massive graphics processing units, tensor processing units, other elements of the compute stack to solve the problem, and development of the vehicle, right? So vehicles for the last century have been developed around a human driver interface. And what that means is they each have a steering wheel that's approximately in reach of most humans' hands, right? They've got pedals, brake, and accelerator that are approximately where a human's feet are. They've got windows where a human's eyes, need to see. And so you have to adapt some of these things so that you've got, in place of the human eyes, you've now got sensors arrayed around the vehicle so they can see things. In place of the human hands around the wheel, you've got a by-wire control of the actuators that control the steering of the vehicle. In place of the human feet, by-wire controls of brakes and accelerator pedals. So those modifications to those vehicles are another part of the problem that gets worked through. In the case of Aurora, the company that I founded, we work through those with many of our vehicle manufacturing partners, several of whom are in the background behind me here: Kenworth, Peterbilt, Volvo trucks, Pacificas, Chrysler Pacificas, Toyota Siennas. Many of these manufacturers are partnered with Aurora in developing vehicles with those interfaces so the self-driving system can operate them.
Awesome.
Self-driving is fundamentally a game of statistics, right? You will never perfectly predict how other actors in the world move. You'll never perfectly be able to predict what the outcome of a particular situation is, should you choose it. And so in self-driving development, the art tends to be that of optimizing for kind of in the presence of these tremendous uncertainties as to where other actors are moving and what their likely response is, not only to each other, but also to you. And so you can imagine the combinatorial complexity of, take a given interaction that happens at an intersection in an average city, thousands of times per hour, right? And that is, you have a vehicle that approaches it. Imagine a bicyclist that's approaching from another direction, another car, a pedestrian. When making these predictions, one is evaluating how each of these actors is likely to move in the nominal case, right? All else equal, if there were nothing else happening in the world and no other actors for whom they were modifying their decisions, how would that pedestrian behave? Would they wait for the light to turn green, or would they go before it turns green? That vehicle, are they going to turn left, or are they going to go straight when they're not running, when they don't have their blinker on, but they appear to be in a position that suggests they would be going left? And so at the end of the day, this is where an elegant combination of rigorous engineering and machine learning tends to be really, really important. And part of the reason that many of the self-driving development companies will be observing real-world behavior of other actors and driving vehicles through the real world is so that we can train effectively very large regression models on the expected behavior of various actors based on small cues of what they're doing, right? Whether that cue is their position in lane that tends to correlate with, X% certainty that their next move is probably to change lanes, or whether it's the, pose of a pedestrian or the size of a pedestrian that may be correlated with their rulemaking or rule breaking tendencies, right? A small toddler, for instance, you or I, through years of experience just as humans, will give more birth to certain individuals. If we see a toddler on the corner of a road, we typically will give them a little more space because we anticipate that their behavior is perhaps less predictable than that of an adult who's standing there looking at you, right? Similarly, we even take very small cues that you and I take for granted because they happen somewhere deep in the neural network that is our own heads, is that we will take a cue from where a person is looking. If we see a pedestrian at a street corner, or we see a driver in another vehicle, if they're not looking in our direction and we can tell they're unfocused or not paying attention, we behave differently. And so there are so many of these cues that you have to learn and train into a self-driving system if you want to improve its forecasting ability to the level of what a human can do.
Awesome. Sterling, I'm curious, you've mentioned now a few different value props, whether that's like ride hailing, ride sharing, or shipping and the big trucks. How have you thought about which markets to tackle first, or do you go
Yeah.
after all of them together?
Yeah.
Who's the stronger value prop?
It's a good question. So just to speak of the markets briefly, trucking today in the United States is an $800 billion market. Over $200 billion of that are driver costs, to say nothing of the efficiency, safety costs that are incurred by the industry that is increasingly subject to nuclear verdicts, very high insurance premiums, reliability problems, particularly for instance, when the pandemic hit, this put in great relief for companies like Amazon, who's an investor in Aurora, putting great relief for them, the real need for a hyper scalable workforce that wasn't subject to the kinds of unpredictability. And in many cases, for many of these fleets, it's 100% turnover. Every year, they're losing nearly 100% of their drivers. And so that's in trucking, really, really opportune for that reason. In ride hailing, this is a $35 billion market in the United States today, about half of which is driver costs, right? So that your typical kind of Uber or Lyft driver, their take is about 80% of the fare that Uber or Lyft are charging. But once you strip out of that the operational costs of owning, fueling, maintaining their vehicle, they're typically the driver wage itself is accounting for about half of the fare. And then finally, in delivery, this is about $100 billion market today in the United States and rapidly growing with the rise of e-commerce. So if you just lay them out that way, you would say, okay, well, from a market sizing and opportunity perspective, it's trucks, then delivery, then ride hailing. If you tack onto that the unit economics, and you start to consider that in the early days of deployment of a self-driving vehicle, its bill of materials is going to be fairly expensive, right? These sensors are prototypes, they're low volume. If you make a toothbrush in 100 unit quantities a year, it's going to be a very expensive toothbrush. The same effect happens with these sensors and computers. And so we're talking about over $100,000 worth of equipment that's being put on these vehicles. The result of that is you need high utilization of the vehicle in order to justify the use of this hardware. And you need very positive unit economics. The labor that it's displacing should be fairly expensive. Turns out in trucking, average truck driver wages span between $30 and $45 an hour. In ride hailing, the average gig economy workers' wages are 15-ish. And so from that perspective alone, trucking is a larger market. It has better unit economics that are better equipped to absorb the incrementally higher amortized bill of materials costs on the early vehicles. And it has a hyper scalable operational domain. And what I mean by that is because trucks drive on roadways that look very self-similar across the United States, developing for a given stretch of highway in Texas allows one to very rapidly scale and expand that to a given stretch of highway in some other state, and rapidly take over kind of that very large market in the United States. So for many reasons, if you can solve the trucking problem, if you can solve the technical challenge, if you can solve the commercial challenges, that is a really, really promising and opportune space, because you can drive up scale, by so doing drive down BOM cost and improve experience. And once you've got lower BOM costs and better experience, you can successfully launch into delivery and ride hailing from a position of great strength, right? Today, what you see is many self-driving development companies, Waymo and Cruise among them, languishing in dense urban environments, taking a very long time to develop anything meaningful. Waymo took the driver out a couple of years ago in Phoenix. Today, they operate a couple dozen vehicles without the driver in Phoenix, Arizona. Phoenix, Arizona is a very easy place to drive, for what it's worth. It's probably one of the easiest in the kind of urban driving space. And yet it's been very, very difficult for Waymo to expand out of that. Cruise had a goal set for themselves in 2019 to pull the driver in San Francisco. They only just semi-pulled the driver. And so each are effectively bogged down in these markets that's really difficult to technically scale. And so by starting in trucking, expanding one's scope and scale, and then launching into these other markets is a really interesting opportunity. And if the next question for you is, okay, then why isn't anybody else doing it? Cruise is owned by General Motors. General Motors doesn't give trucks, therefore General Motors doesn't care about the trucking market. B, Waymo. Waymo is owned by Alphabet. They should presumably have some interest there, but for two reasons, they're not nearly as focused on this market as one would expect they would be. One, I think Larry and Sergey prefer the kind of direct-to-consumer elements of the ride-hailing space. And two, technically, no one but Aurora today has the ability to see at the kind of ranges that you have to see to drive a self-driving truck at highway speeds. Right? This is an 80,000-pound vehicle moving at 65 miles an hour. If something happens on this truck, someone dies. This is not a small vehicle driving 25 miles an hour in a city. This is enormous stakes for this to happen. And so the consequence or the implication of this is, because such a vehicle operating at such speeds requires so long to stop, you need to reliably be able to see well beyond 300 meters ahead of you. And the problem is, right now, the LiDAR systems that all of the industry has, save one, and that's Aurora by right of an acquisition that we made a couple of years ago, are limited to see about 200 meters out. When you can only see 200 meters out, imagine you as a human driver. The analog here is, imagine driving into a dense fog where you can only see 200 meters ahead of you. Imagine driving at 65 miles an hour in that. You would be crazy to do so. You would be really gutsy if you did that. And so most humans don't. Now imagine being asked to drive an 80,000-pound truck at 65 miles an hour into that same fog. Most of you wouldn't do that. Now, the challenge is, for any other self-driving developer to attempt a problem like this, they would have to be willing to ask their self-driving system to do just that, because that's as far as they can reasonably see with multiple modes. And so from that perspective, Aurora is somewhat unique. We have unlocked technically the ability to see at much longer ranges. Therefore, we can operate first in trucks and then successfully in ride hailing and delivery. We recently acquired Uber's ATG program. That was a self-driving program. There's about almost 1,000 people that joined Aurora through that acquisition. That was a really important move for us for three reasons. Uber ATG had quite a lot of very strong talent through the organization. They had strong partnerships, and they had good technology. What they also had is a relationship to Uber. Uber, obviously, having built a tremendous ride-hailing network in the United States and beyond, has a tremendous amount of information as to where and how people move. That is really is a huge strategic opportunity for Aurora to know exactly where to target our self-driving systems capabilities. And so that's kind of a little bit of what was behind that acquisition. The industry, as we've said for years, is and will continue to consolidate. It's just too difficult a technical problem to be solved by a lot of small players that are undercapitalized. So, fortunately, Aurora is in a position now where we're 1,600 people. We're very well capitalized with a very strong set of supporters on the capital front, and yeah, we're excited about it. I led the program at Tesla through its first and second generations of autopilot. We were solving a different problem there, right? Tesla has to sell cars. As a result, Tesla has to release hardware that is inexpensive enough for a general user to buy it, which puts them at a tremendous disadvantage as it relates to the development of a very complex technology that is really benefited by having sensors of the kind of performance and modality coverage that Tesla can't afford because its owners can't afford it. So Tesla does have a lot of vehicles deployed on road, and that is a tremendous advantage for them. What Tesla does not have is vehicles on road equipped with the kind of sensors and compute that it needs to solve the problem anytime in the near term. And so my expectation is that while I can't promise you Elon won't try to release full self-driving capabilities, what I can tell you is it is extraordinarily unlikely that he's able to release an actually safe full self-driving system before the rest of the industry gets there. In fact, I expect that Tesla on its current hardware is decades behind.
Sterling, I know we've got to let you run. Thank you so much for your comments, your thoughts. This is a deep technical dive. We don't normally get treated to such. So thank you again. If we can all give Sterling a round of applause, appreciate you joining us here at UC Davis. And best of luck with Aurora. We're looking forward to big and even better things than you've already accomplished. So thank you very much.
You bet. Nice to meet you all. Take care.
Take care, Sterling.